In this video, we are going to look at the formula for an arc length, area of a sector, area of a segment, and where those formulas come from. To answer questions that require knowledge of these three formulas, you also must be familiar with sine rule, cosine rule, and the formula for the area of a triangle, which come up in A-level maths, but we're not going to go into here. To begin with, let's look at the arc length. I've got a diagram here of a sector. You can see the angle of the sector is theta and the radius of the circle is r. And then the arc length is represented with the letter L. And that's just by convention for A-level maths. Okay, first of all, the formula. There it is. Arc length equals the radius times the angle size. And I should just make this point now that the angle must be in radians for this formula to work. Okay. Alright, so where does this formula come from? Well, if you like, you can think, one way to think about it is to work out this arc length, it's a fraction of the whole circumference. How do you work out the circumference of a circle? It's 2 pi r. So we just want a fraction of this circumference here. And the fraction you need is the angle divided by the number of radians in a full revolution. To be more specific, the fraction of the circumference is theta over 2 pi. Okay. And if we take that fraction of the circumference, it simplifies to, well, the pi's cancel, the 2's cancel, and we're left with theta r. And we're done. Okay, next up, how do you work out the area of a sector? First of all, what is a sector? I always picture it a bit like a slice of pizza, if the pizza's in a circle. And you can see here, this pizza slice shape is my sector. And I've used the capital letter A to represent the area. The formula. Is that a half times the radius squared times theta. Again, theta must be in radians. Cool. And then where does the formula come from? Well, you can derive it in a very similar way to the arc length. Okay, first of all, question is, what's the area of a whole circle? Pi r squared, hopefully you're familiar with that. And then this sector is just a fraction of the full circle. And the fraction that it is of the full circle is theta over 2 pi. Remember, 2 pi is the number of radians in a full circle, and we've just got theta. So we want that fraction of the full circle. Times them together. Our area equals that. Okay, and again, it's just a question of simplifying. The pi's, you can strike them off, and we're left with theta over 2 times r squared, or a half theta r squared. Oh, again, I've written it the other way around there. Finally, how do you work out the area of a segment? Right, firstly, it's important to make a distinction between what a segment is and what a sector is. So in my diagram down here, let's have a quick look. I've got a sector here clearly drawn, this pizza slice. If I were to draw a chord from this point to this point, like so, then this little bit on the edge is your segment. I'll use A for the area. So if the sector is a pizza slice, perhaps you could think of a segment as the crust of the pizza. All right, and the formula to work out the area of a segment is again, all angles must be in radians. Okay, we're going to have a quick look where this formula comes from. It takes a little bit longer to work it out. All right, to get the area of the segment, which I'm going to call A, it is the area of the whole sector take away the area of this triangle. Let's write that down to begin with. The area of the whole sector we already know. Let's do this in blue, excuse me. There's the area of the sector. Take away the area of this triangle. Okay, there's a formula for the area of a triangle, which is a half AB sine C. That's the formula for the area of the triangle. So we need to sub the information in here to our formula for the area of a triangle. Okay, A and B, they're two lengths of sides on the triangle. So we've got R and R as the lengths of our sides. So this is going to be a half R squared. Sine C, capital C, that's an angle, and it's the angle between the two side lengths. So it's theta. Okay, so area of the sector, take away area of the triangle. And then you factorise. The common factor here is a half R squared. And we're done.